All right, so today we want to be able to recognize rational and irrational expressions. So let's look at each of these expressions. It says here, indicate whether each number is rational or irrational. Now we know already that the square root of 2 is irrational, and we know that pi is irrational, so if you add them up, you're still going to have an irrational. All right, let's look at the second one, the cube root of pi. Okay, the pi is irrational, so if you take the cube root of it, you get 1.464591, and the decimal just keeps on going. Now the question is, could we write this? Okay, now the cube root of pi is the same thing as pi raised to the 1/3 power. So the question is, could we write this as a fraction? And I just don't see how we could, and this is a decimal that goes on and on without repeating. So I'm going to say that this is irrational. Okay, notice our decimal goes on and there is no pattern here. All right, this one right here says the square root of 2 times pi. So if we take 2 times pi and then we take the square root of it, look here, the square root of 2 is irrational, and pi already itself is irrational, so I'm going to say this whole one is irrational. Now you can type it in the calculator, the square root of 2 times pi, and it gives you 2.506628, and it just keeps going on and on forever without a pattern, so it's irrational. All right, here I have the square root of pi plus 1. I'm going to put that in the calculator, and it tells me that it is 2.035090, and it goes on and on forever without a pattern. So it also is irrational. Now, look at this one. This is a good one. Okay. At first glance, it looks irrational, right? But let's keep studying it. So what is pi over 2 minus pi over 2? Because I have a pi over 2 here, and I have a negative pi over 2 there, and that gives me 0, right? And then if I just add the 2 that's there, 0 plus 2 is 2. So is 2 rational? It sure is, so this is a rational. So even though there is a pi involved in that one, it's still rational, because when I evaluate it, I get a rational number, which was 2. So this question is a little more difficult. It says, let A and B be non-zero rational numbers. So A and B are going to be numbers like 2 or 6. Okay? That A and B are going to be numbers like 2 and 6 because they're rational. And let C and D be irrational. Let's say like C is pi and D is the square root of 2. And I'm just giving examples. That's not what they have to be. And then it wants to know, would A times B plus C be rational, irrational, or both? It could be rational or irrational depending on the individual moment. So let's say A was 2, B was 6, and C is pi. Okay, well, if I have 6 plus pi times 2, that's irrational. But now let's think, is there a way that I could ever make that rational? I don't think so. And so that's going to be irrational. Now, the reason I was saying, is there a way we can make it rational, is let's say that I did like, let's say that I was able to add like pi plus negative pi and get 0. Then I could make it rational. But in this case, since there's only one irrational number, I can't add it to another irrational number to make it rational. Let's try the second one. The second one says the square root of 5 times A all squared. So what that means is, it means the square root of 5 times A times itself. The square root of 5 times A, like that. And so let's evaluate that. So that'll be the square root of 5 times the square root of 5 is 5, and A times A is A squared. Now let's take a rational number and put it in for A, like 2. So that'd be 5 times 2 squared, which is 5 times 4, which is 20. Well, I don't really see a way for me to plug a number that's rational in for A here and get an irrational out. And so I think it's always going to be rational. Let's look at the third one. A cubed times D. So it's saying take a rational number and cube it. Well, it's still rational. And multiply it by an irrational number. And so if I take A cubed, let's say my A is 2. Well, 2 cubes 8. And then my D is, say, pi. Well, that'd be 8 pi. And 8 pi is irrational, and there's really not a way to ever make it rational. And let's look at the fourth one, this one. A times D plus AB squared. A times B plus AB squared. So I'm taking a rational and multiplying by another rational, and I'm taking a rational and multiplying by a rational squared. So we're dealing all in rationals here. And so since we're dealing all in rationals, it's going to be rational. And then let's look at the last one, D to the fourth. So D to the fourth means we're going to take like square root of 2 and raise it to the fourth power. So that's the same thing as the square root of 2 times the square root of 2 times the square root of 2 times the square root of 2. So square root of 2 times square root of 2 is 2, and square root of 2 times square root of 2 is 2, and 2 times 2 is 4. Well, look at there. We took an irrational number and made it rational. Okay, but now let's say my D was pi. Pi raised to the fourth power is still irrational. And so right here, whenever I took an irrational number and raised it to the fourth, I got an irrational. But over here, when I took an irrational and raised it to the fourth power, I got a rational. So in this case, what do you think? I think that it could be either.